So this video is 7.5, and in this section, we're going to talk about hypothesis testing for variance and standard deviation. So to do this, we're going to be using the chi-square test. So what you want to make sure that you do is specify your level of significance and find your degrees of freedom by subtracting 1 from your sample size. And then we have three new things that we're going to talk about. So if we have a right-tailed test, you're going to use your degrees of freedom and the corresponding alpha significance level. If you have a left-tailed test, you are going to use the corresponding degrees of freedom, and you are actually going to do 1 minus alpha. So this is new. Oops. Okay. Take 2. Seems like my pen is not wanting to work right now. Okay. And if you were doing the two-tailed test, then you are going to use the degrees of freedom that corresponds to 1/2 alpha and 1 minus 1/2 alpha. Okay. All right, so here is a picture of what this looks like. And you'll notice the right tail test is shaded to the right, the left tail test is shaded to the left, and our two-tailed test has 2 shaded regions at the end. Okay. All right, so let's knock this out with an example. So we're just going to start by finding critical values, and I'm actually going to plug up my pen and see if that makes a difference here. Okay. All right, so okay, so it wants us to find the critical value for a left-tailed test. Okay, so that's important. Left-tailed test. Come on, there we go. Now my pen's working. Our sample size is 11. Still being a little picky. And our alpha significance level is 0.01. Okay. So the first thing that you need to take note of is our degrees of freedom. So in this case, our degrees of freedom is going to be 11 subtract 1, which is 10. Now, being that we have a left-tailed test, the rule for the left-tailed test is you're going to do 1 subtract alpha. So in this case, that is 1 minus 0.01. And if you do that, you're going to get 0.99. And so then what you're going to do is you're going to go to the back of your textbook, and it's chart number, I want to say it's on page A17 or 18. You're going to go down to 10, and then you're going to go over to 0.99. And if you do that, you're going to get a chi-squared value of 2.558. Okay, so I'm really bad at drawing the chi-squared symbol, especially since I now have to do this with my mouse because my pen is not working. Okay, so that's going to be 2. Ooh, that was really bad. Try that again. 2.558. Okay, so let's do another one. So in this case, we are now performing a two-tailed test, and our sample size is 9, and our alpha is 0.05. Okay, so the first thing that we're going to note is our degrees of freedom. And in this case, our degrees of freedom is going to be 8, and I get that by subtracting 9 minus 1. And then we have 2 things that we need to do for this. So the first thing that we're going to do is we're going to do 1 minus alpha divided by 2. And so if I do that, that is going to be 1 minus 0.05 divided by 2, which is going to give me 0.975. And then the other thing that we have to do is alpha divided by 2. So alpha divided by 2 is 0.05, which is 0.025. Okay. All right. So once you have these two values, you're going to end up with two chi-squared values, one on the right and one on the left. And so our left value is going to be 2.180, and our right value is going to be 17.535. Okay. All right. So let's run through a few more things and then we'll do some more examples. So our chi-squared test, this is useful when we are working with our population variance or standard deviation. Per usual, our population needs to be normal. Our test statistic is going to be our variance, and the standardized test statistic is represented by the following formula. So let's run through our steps. So first, of course, you always want to make sure your sample is random and the population is normally distributed. You're going to state your claim mathematically and then identify your null and alternative hypothesis. Identify your level of significance. This is your alpha. Find your degrees of freedom using the following formula, and then you're going to find your critical values. Okay. So you want to determine your rejection region, then you're going to find your standardized test statistic. And sometimes it does help to sketch a picture of what it looks like so that you know where the rejection region is. And then from there, you're going to make a decision to reject or fail to reject. And then you're going to write a summarizing sentence to interpret your decision in the context of your original claim. Okay, so first example. So we have a dairy processing company and they claim the variance of the amount of fat in whole milk processed by the company is no more than 0.25. You suspect this is wrong and you find a random sample of 41 milk containers has a variance of 0.27. At an alpha level of 0.05, is there enough evidence to reject the company's claim? Assume the population is normally distributed. Okay, so let me see if my pen is better. I really wanted it to work. Okay, maybe if I just write really slow. No, it's just so picky. It's a curious thing. Okay, so claim is the variance. I wonder if I have variance on here. Let's see. Okay, yep, that'll work. So variance is less than or equal to, oops, not hands. Oh, that's funny. Less than or equal, oh, poop. Okay, there we go. Less than or equal to 0.25. So the corresponding statement that's opposite of that is that it is greater than. So copy this. Is greater. Then 0.25. Okay, there we go. So which one of these is my null? Here's my null. H not, which means this guy is my alternative. H A. Okay, so things that I'm noticing that this is going to be a right-tailed test. Let's do blue. Okay, so this is a right-tailed test. So remember, you can tell based on your null hypothesis. And the other thing I know is that n is 41, which means my degrees of freedom is 40. And my alpha level is 0.05. So since this is a right-tailed test, I don't have to do any other work with my alpha level. So from my chart in the back of the book, I'm going to get my chi-squared value of, I'm going to write that out so I don't have to try to draw the symbol. And it is equal to 55.758. Okay, so what does that mean? Okay, so since this is a right-tailed test, that is telling me that this value right here on this line is 55.758. So my rejection region is going to be anything greater than that. Okay, so rejection region is values greater than 55.758. I was trying to see a way I could summarize that a little bit less, but no bueno. Okay, so let's go ahead and use our formula. So our formula, remember, is our chi-squared. I always have to look at this before I try to draw it. Okay, so it's going to equal n minus 1 squared. Oh, that's so bad. Over. Okay, can you even read that? Let's try to make it a little bit nicer. So I'm writing with my mouse since my pen is not working. Because I already restarted once, I'm not going to restart my computer again. All right, so degrees of freedom is 40. I'm going to multiply that by the 0.27 divided by 0.25. Okay, so if I do that, I'm going to get 43.2. Okay, so is 43.2 greater than 55.758? And the answer is no. So that means we're going to fail to reject. Okay, so fail to reject. So we're going to say there is not enough evidence at the 5% significant level to reject the company's claim that the variance amount of fat in whole milk is not more than 0.25. Okay. Oops. All right, let me scroll back down. All right, come on, scroll back down. All right. There we go. Okay. Next. So the company claims that the standard deviation of lengths of times it takes An incoming telephone call to be transferred to the correct office is less than 1.4 minutes. A random sample of 25 incoming telephone calls has a standard deviation of 1.1 minutes at an alpha level of 0.10. Is there enough evidence to support the company's claim? Assume the population is normally distributed. Okay, fantastic. So let's go with our claim. Our claim is what? That it is transferred to the correct office in less than 1.4 minutes. Okay, so okay, it is less than 1.4. So the corresponding statement opposite that would be okay, so let's identify our null. In this case, this is my null, and this is my alternative. All right, so what else do I know? I know that we have a sample of 25, which means my degrees of freedom is 24. The standard deviation of my sample is 1.1 minutes, and my alpha level is 0.1. Okay, and we need to identify what kind of test this is, and this is a left-tailed test. Okay, so we have to do some work for the left-tailed test. What do we have to do? We have to do 1 minus alpha. Okay, so in this case, it is 1 minus 0.1, which is 0.9. And so that is the value that we're going to look at on the chart, going down to 24 degrees of freedom. And if we do that, we're getting a chi-squared value of 15.659. Okay. So our rejection region is going to be anything less than that, okay, since we're doing a left-tailed test. So what does that look like? It looks like that. And my 15.659 is right there. So we are rejecting anything less than that, okay? All right, so let's go ahead and, oh, I didn't write down my standard deviation. 1.1, okay. Let's go ahead and we'll write down our formula. So we're gonna do, let me see how I wanna do this. I'm gonna try to type it. Okay, so chi-squared equals n minus 1 times s squared. And that is all divided by okay. Hope that is a very fat line. Okay. All right. We're gonna make it work. Okay, so that is going to equal 24 times 1.1 squared, all divided by 1.4 squared. 4 squared. Okay, another line. Oop. Make it a little bit skinnier. There we go. Look at that. That's nice. Okay. All right, so if we do that, we are going to end up with an answer of 14.816. And the question is that in our rejection region? And the answer is yes, because that is here. Okay, and that's my rejection region right here. It's my rejection region. All right, so we are going to reject H naught. Okay, so summarizing sentence. There is enough evidence at the 10% level of sig significance to support the claim that the length of time it takes an incoming call to be transferred is less than 1.4 minutes. All right. Hopefully I spelled everything right. All right, let's do one more example. So we have a sporting goods manufacturer, and they're claiming that the variance in the strength of a certain fishing line is 15.9. Excuse me. Oh my goodness. A random sample of 15 fishing line spools has a variance of 21.8 and an alpha level of 0.05. Is there enough evidence to reject the manufacturer's claim? Assume the population is normally distributed. All right, so let's go ahead and identify our claim. So our claim in this case is the variance is 15.9. So the corresponding opposite claim to that is not equal to 15.9. Okay, so in this case, we have H naught being our claim. And this is my alternative. And this is going to be a two-tailed test because we have the equal sign. Okay, so since this is a two-tailed test, we're going to have two chi-squared values. And to figure that out, we're going to do two things. We're going to do 1 minus alpha divided by 2 and also alpha divided by 2. Okay, so 1 minus alpha divided by 2 is the same as 1 minus 0.05 by 2, which is 0.975. And then we're also going to do alpha divided by 2, which is 0.05 divided by 2, 0.025. Okay, so we're going to get two chi-squared values from that. We are going to get 5.629 and 26.119. So I'm going to draw a picture. So we're going to get 5.629, 5.629, and 26.119. And remember, I'm getting this by looking at the significance levels of 0.975 and 0.025. And my degrees of freedom in this case is 14, since my sample is 15. Okay, so we have two rejection regions. Anything that is less than 5.629 and anything that is greater than 26.119. Okay, so now let's go ahead and do the formula. I think I'm going to try to type it again because that worked so well last time. So squared equals Oh. Okay. All right. So I'm going to get 14 times 21.8. And we're dividing that by 15.9. 15.9. And if we do that, we are going to end up with an answer of 19.195. Okay, so the question is, where does that value lie? And that value lies in the middle here. So do we reject? Nope, we do not. We fail to reject. Okay, so let's write our sentence. There is not enough evidence the 5% level of significance to reject the claim that the variance of fishing line is 15.9. And done.